Yes, we are live. Steve, are you there?
Yes, we just started the broadcast
And the recording is not on yet. Rhonda is the host.
now the recording is going as well.
But I don't see it.
Because you're the co-host.
Okay, because we want to make sure the recording is started before we get...
The recording is started and we're live on YouTube right now.
Okay. So, Dr. Khan, you see the recording?
Yeah, it's going on, ma'am.
Okay. Welcome, everyone. Good morning, or good afternoon, or good evening from wherever you are at this time. And we welcome you to the first ever Women in Data Science Dallas event to be held at the IEEE ICDE 2020. And also, we are an ambassador to Stanford University's WIDS initiative. It's a global, worldwide Women in Data Science initiative, and it was founded by our keynote speaker, Professor Margot Gerritsen. So before that, I will tell you a little bit about IEEE ICDE 2020 and how we got to organize a WIDS Dallas event. So ICDE 2020, this is the 36th ICDE, and it was supposed to have been face-to-face in Dallas, Texas from April 20th through April 24th. Unfortunately, we had the worldwide pandemic, COVID-19, and so initially we were planning to postpone it to sometime in the fall. But then after some meetings, the steering committee, the technical committee, and the organizing committee together with IEEE decided let's have it virtual, and that decision was made only on April 1st. So we had just 19 days to put together the conference. Now, I have two roles. I'm the general co-chair of the IEEE ICDE, and I'm also the co-chair of this WIDS Special Dallas event together with my colleague, Professor Latifa Khan. So we have had so far 4 days of very successful conference. April 20th, we had the workshops, and Tuesday through Thursday, 21st to 23rd, we had the main conference with the keynote speakers, the tutorials, and we had many sessions, and as well as our sponsors, including Qatar Computing Research Institute, Alibaba Group, and the platinum sponsor, University of Texas, Dallas. They all gave short presentations at the conference. We have 2,000 people registered for the conference, and so we sent out the invitation to all of them to join this special event. And thanks to Stanford WIDS and IEEE, we are also able to live stream, not the entire event, the opening, as well as the keynote presentation of Dr. Gerritsen. So it took so many people. As I said in my opening statement on Tuesday, it took the world to make ICDE 2020 and the WIDS Dallas event happen. And what we are hoping is to have this WIDS event in different cities where we are going to host ICDE in collaboration with the Stanford WIDS to host it every year. So the current plan is for this conference to be in Greece next year. They have not confirmed it. And so we may want to take it there next year, together with Stanford and ICDE. So we have an excellent list of speakers, but before that, I would like to thank, most of all, our sponsor, the National Science Foundation, Dr. Li Yang. She's actually Professor Li Yang, but at her current role as Program Director at NSF, she's Dr. Li Yang. So she will be saying a few words. And before the keynote speaker talks about it, and gives a talk. So the main goal for us is to promote the WIDS Stanford effort initiative. It's hugely popular. I myself was a speaker in the 2008 WIDS conference at Stanford, and that really motivated me to continue to promote WIDS at different events. So I thought ICDE 2020, because it's a top data conference, it will be, and also sponsored by IEEE, it will be a good venue for us to organize the WIDS event. So as I said, we have excellent list of speakers, and we hope that you will stay till the end. We have, of course, Dr. Li Yang giving the opening remarks. And then we are having Dr. Gerritsen, followed by her keynote, followed by the featured address by Professor Elisa Bertino from Purdue. And then we have Professor Ling Liu from Georgia Tech. And then we have Professor Eunice Santos from University of Illinois. And then we will also have Professor Mei-Ling Xu from University of Miami, Professor Daphne Yao from Virginia Tech. And then we have Professor Ying Ding from University of Texas, Austin. And then Professor Karuna Joshi from University of Maryland, Baltimore County. They are all excellent researchers in data science, and some of them also in data science and security. And then we are going to have a panel where we are going to discuss various issues and challenges faced by women in data science. So some of the speakers today will also be panelists this evening. Now, as I said, part of this, the first part until Professor Gerritsen's talk, it's going to be also live streamed to all of the WIDS members. They have 150,000 members. We would have loved to have also let them into this Zoom, but we only have a capacity of 2,000, so it would have really broken the entire system. So we are also live streaming. And we are going to put all of the presentations and the discussions and so on YouTube. So at this time, I want to hand it over to my colleague and co-chair, Professor Latifa Khan, to say a few words for about 5 or 6 minutes. And after that, I will introduce Professor Lee, Dr. Lee from the National Science Foundation. So I hand it over now to you, Dr. Khan.
Okay, thank you, Professor Bhavani. My name is Latifur Khan, and I'm truly honored to co-chair this very special event, WIDS Dallas, as an ambassador to WIDS Stanford at ICDE 2020. I have served as co-chair of WIDS Dallas at UT Dallas every year since March 2018, and it has been very gratifying to see so many talented female students participate in this event. It has also helped me to recruit female students to pursue a PhD in data science. Furthermore, Professor Bhavani and I have co-advised many female students together. I also teach an extremely popular class called Big Data Analytics and Management at UT Dallas, and I encourage several female graduate students to take this class or course. Many of our MS students in data science have obtained lucrative jobs in the industry. I'm looking forward to working with WIDS Dallas for many more years to come. Thank you. So I would like to transfer to Dr. Bhavani. You can start now.
So thank you, Dr. Khan. As you see that for us to thrive as women, we also need the support of men. And Professor Khan is one such man who is my colleague, PhD from University of Southern California. and we are both at University of Texas at Dallas. And Professor Khan has been a very strong supporter of women in data science. And he and I have supervised, co-advised several female PhD students. And he also has the most popular class in big data analytics. And he has numerous female students who study data science. So thank you very much, Professor Khan, for your support to women in data science. We really appreciate it. Now, I'm going to introduce our sponsor, Dr. Li Yang. She is a program director at the National Science Foundation, and she heads several initiatives in the NSF's Education Directorate, both in cybersecurity as well as in data science, and in particular at the intersection of cybersecurity and data science / artificial intelligence. So a short bio, Dr. Yang is the Gehry Professor in the College of Engineering and Computer Science. So she's at the University of Tennessee in Chattanooga. So she is also, a professor there, and she is extremely well known in her research in the area of information security. And so she is also manages the university's National Center for Academic Excellence in Information Assurance and Cyber Defense. Her research interests include network and information security, mobile security, big data analytics, massive data mining, bioinformatics, as well as various education activities, educating complex systems. And she's a program director, as I mentioned, at the National Science Foundation. And she also works closely with the Oak Ridge National Laboratory. So I'm going to ask Professor Li Yang to say a few words about this conference, this particular workshop, and they have supported our WITS events as well in the past. And so we are very grateful to the National Science Foundation for supporting this event. So Dr. Yang, do you want to say a few words?
Yes, thank you for the introduction, and good morning, everyone. It's so nice to see all of you. My name is Li Yang. I work as a program officer in the National Science Foundation in 2 programs mainly, and one program is in the Cyber Corps, also called the Scholarship for Service. The other program is in the Secure and Trustworthy Cyberspace in the Education Designation. So it's great to see all of you, and I hope you and your loved ones are safe and healthy during this pandemic. And we will go back to see our colleagues and students very soon. I want to say thank you to Dr. Bhavani Srisantham and Latifah Khan, who organized this Women in Data Science workshop. And also they connected me with this amazing workshop, Women in Data Science. It's so exciting to see we have so many women scientists and leaders in the field of the data science as well as computing. So I want to say thank you to the Dr. Margot Garrison founded this amazing community. It plays a very important role to connect women in data science and also provide a supporting platform for all of us. And I read the schedule. All the speakers has like very impressive background. They are leading figures in the field, like Professor Alisa Bertino, Ling Liu, Eunice Santos, Mei-Ling Shu, Daphne Yao, Ying Ding, and Karura Josh. They also as a role model for many of the female junior scientists in the field of junior faculty and students. They also pave the road for all the students, faculty, and scientists, and then this will really help them to grow their career in the future. So data science is very important when everything becomes intelligent. So data science is important, and the data science usually go with the security and the privacy. Dr. Bhavani and Latifa, two of them helped us to organize a session in the SASE PI meeting in November last year. And then the topic was trying to explore and investigate how the artificial intelligence and the cybersecurity, as well as education, those three areas, they can converge and then generate something that is transformative, which will benefit all the three disciplines based on their work. And then I want to share one of the funding opportunities is through the Dear Colleague letter. I'm going to share the link through the chat later on. So if you want to search, the number is called 20-072. The title is Cybersecurity Education in the Age of Artificial Intelligence. And then in this Dear Colleague letter, which is driven by several of the reports. One report is the National Strategy in Artificial Intelligence. The other report is the Federal Cybersecurity Research and Development Strategic Plan. And all of them, they highlight the mutual needs and the benefits of the AI and the cybersecurity. And the AI can help to enhance the cybersecurity by assisting the human systems through automating a lot of activities such as monitoring, analysis, and response to adversary attacks. And at the same time, it is essential for us to guard the artificial intelligence technologies from unintended uses and hostile exploitation by using many of the existing cybersecurity practices that we have learned over the past years. The research results at the intersection of the artificial intelligence, data science, as well as cybersecurity can lead to a lot of changes for us to understand the fundamentals of the cybersecurity, and then give us some new ideas how we can motivate and educate the students about the cybersecurity in the age of the artificial intelligence. A lot of things fundamentally has changed. Like we started with computer networks, and then we have computer network security. We have a database, and then we have a database security. Now we have artificial intelligence and how to secure and make trustworthy artificial intelligence is the question for us to work on. So all together, we look at the basic research. We look at the basic research in the cybersecurity, as well as we look at the education research, how to innovate the ways that we are educating. Like now we are moving everything in the distance, remote. And then will this give us ideas and how we prepare for future disaster like this, and then how to make everything ready? That's the question that for the research community as well as the education community to look on. So this Dear Colleague letter is trying to inspire and encourage the collaboration from three fields: the AI research, the cybersecurity research, as well as the education research. So I hope that we will get some of the submission from this community. And then the first step is to submit 2 pages. The 2 pages, we have 2 deadlines. One deadline is May 15, the other deadline is August 31st. And then we will review after the deadline. So we will, it's not like rolling base. We will wait until the May 15, and then we start to read the 2 pages. The 2 pages will include the title, some of the summary, and then if the 2-page summary is invited, and the team will submit a eager proposal. So eager is a mechanism at NSF trying to encourage the exploratory work in the early stage. And then basically it's a high risk and high payoff that will apply the new expertise, engage novel disciplinary or interdisciplinary collaboration as well as research. So basically the 2 things we are looking for, one is the collaboration among the 3 areas. So if you have like one faculty that has the 3 areas, 3 expertise, then that works. And if one faculty is in AI and one faculty is in cybersecurity research and education research, that will work as well. It can also use like a collaborative form among more than one institution. So I want to say thank you one more time for this amazing workshop to happen, and especially you are very innovative to move the workshop online. I hope the success of the workshop, and let's stay connected. Feel free to contact me for any of the question, or if there's anything I can help. To say thank you.
Thank you. Thank you very much. Yes, thank you very much, Dr. Lee, for again sponsoring and for giving these opening remarks, and also giving us some inputs about the various programs. Of course, there is the upcoming announcement that you have made about the upcoming opportunity about cybersecurity in the age of artificial intelligence, and then I'm sure it's also data science. And in addition, NSF also has opportunities of the Artificial Intelligence Institutes. So before I introduce our very prestigious honorable keynote speaker, I'll be stop sharing, and so then she can load her presentations in a minute. So that's what I'm going to do, so that our speaker can load her presentation. So one of the things that I wanted to also mention, because I'm going to start introducing her so that she starts her talk on the dot at 9:30, because that's when it's all going to, it's being live streamed now, but so many people are anxiously looking forward to listening to a presentation. So one of the things I wanted to mention, as I said, because we decided to start this conference, organize this conference April 1st to go virtually. So the last 19 days, we were really busy because we have 5 days of conference, right? The workshops, the main conference, and now the special events. So we work with IEEE and also the organizing committees. So we want to thank IEEE, Patrick from IEEE, as well as Steve Wood, who is here, who has helped us also to link the Zoom stream with the live stream, YouTube live stream, so that all of the WIDS members, and I believe there are around 150,000 of them, so that they could also listen to Professor Gerritsen speak. Okay, and another thing is, if we had had more time, I would have liked to have made this special day really global. As I said, invite all of our colleagues in Europe, from Asia, and from South America, North America, Africa, Australia, around the world, to also participate. But as I said, unfortunately, we didn't have as much time to get everything organized. And so we just had the US, the speakers only from the United States. So hopefully future conferences in collaboration with the Stanford WIDS team, we are hoping that the ICDE 2020, we can have one day, perhaps the last day, so that we can accommodate the global audience. And hopefully we can continue to have this virtually. So one more thing I wanted to also mention is that when Dr. Gerritsen is speaking, what I would like for all of us to do is to stop our video as well as mute. It's really important so that there is really no distraction, so everyone can really focus on Dr. Gerritsen's speech. So if we can all please do that, if you can all please now stop your video, and then and also mute. Okay, if you can please do that. I see there's still some, Dr. Khan. If you can please stop your video. Okay, thank you very much. And I will stop mine. Okay, so we have another 4 minutes left, and I don't want to take too much time into Dr. Gerritson's talk, but I just wanted to start at 9:30 because the whole world practically will be watching her keynote address. So one of the things that we are finding towards in the panel, I just wanted to add that at the panel today, we are going to discuss some of the successes that we have had in data science. So panelists will address all of the great things that are happening in data science for women, and as well as some of the challenges we are faced with, right? Because when you look at most of the professors, the department heads of computer science, almost all of them are men, although it is increasing, as I was mentioning at an earlier workshop we had a few weeks ago on women in cybersecurity research that Professor Daphne Yao organized, also virtually. We discussed the problem of more men as department heads in computer science. And so we really have to work towards increasing the number of women. And so that's the one way that we can then increase more of the women faculty. And as a result, we can attract more female students. So if I compare cybersecurity and data science, as I have always, for the last 2-3 years, I've been looking at various surveys and so on. Data science results are more encouraging. I think we have around 25-30%, even in our classes, whereas in our cybersecurity classes, it's very low. It's around probably 10% or even less. And there is a lot of interest now of integrating data science for cybersecurity. And this is one of the areas. There's a lot of focus on applying data science to cybersecurity, so many cybersecurity problems, and also cybersecurity to data science. And especially with COVID-19, there are enormous opportunities to data science. And so that's something that we really want to take advantage, and so that women can really thrive in data science. Okay, so now we are almost arriving at 9:30, and I would like to introduce our keynote speaker. And we are really grateful to the Stanford WIDS organization, because they have really motivated so many women in data science all over the world. I was so impressed when I attended WIDS 2018, and we have been an ambassador since then, and it's just amazing. And who better to have for this opening keynote than the founder of WIDS? So it gives me great honor and pleasure to introduce to you Professor Dr. Margot Gerritsen. Dr. Gerritsen is a professor in the Department of Energy Resources Engineering at Stanford University. She is also Associate Dean for Educational Affairs in the School of Earth, Energy, and Environmental Sciences, as well as the co-director of WIDS, and as I said, the founder and the host of the WIDS podcast. Her primary research interests are in sustainability and renewable and fossil energy production. Dr. Gerritsen received a PhD in scientific computing and computational mathematics at Stanford University. Before returning to Stanford as a faculty and a professor in 2001, after her PhD, she spent nearly 5 years in Auckland, New Zealand, as a faculty member in the Department of Engineering Science. Dr. Gerritsen has received many awards and she is just the person, women in data science. It is Dr. Margot Gerritsen. So Dr. Gerritsen, it's all yours now. Thank you very much.
Thank you so much, Bhavani. I hope you can all hear me okay and you can see my screen.
And Dr. Gerritsen, just one thing. So the participants who are present, please write your questions and answers, Q&A, so that we can read out to Dr. Gerritsen at the end. Thank you.
Great. Yeah, there is a Q&A button for all attendees, and this is how you can submit your questions. And I would love for you to do that. And I will make sure that by the end of, or near the end of the talk, I have some questions to answer those. And the nice thing about having these sort of virtual meetings is that there is a record of all questions. So afterwards, if we're running out of time, I can still address all of those questions to you as well. So it's such a pleasure to be here. It's a little strange to be here in Silicon Valley. I'm actually closer to the coast now in Santa Cruz at 7:30 in the morning. This explains my little cup of coffee. But speaking in Dallas, I've spent much time in Dallas over my career and have really great memories. I would have loved to be there in person. But this is a good alternative, and thanks also to Latifour and Lee, and especially Bhavani, who I met several years ago when she came, as she mentioned, to one of our first Women in Data Science conferences. So my accent, that no doubt you're spotting, is Dutch. I am a computational mathematician. I grew up in the Netherlands and lived there until I was around 24. Did a master's in mathematics, theoretical mathematics, and also a bit of what we call industrial mathematics. And then moved over to the United States, where I did a PhD ultimately at Stanford University in what we call computational mathematics or scientific computing. As Bhavani was saying, I came back to Stanford in 2001 after wandering around the planet for a little bit and really started working in the energy space. And this has been really interesting. I spent quite a lot of time working first in the fossil fuel industry, mostly in an effort to help mitigate harmful environmental impacts of oil and gas. And gradually, this whole field, at least at Stanford in the department, we're moving to low carbon and no carbon energy systems, low cost energy, and also distributed energy systems. So most of my work now is in the energy spaces in this area. But I also have always loved computational mathematics, and data science, of course, is part of this. This is at least how we computational mathematicians see data science, that computational math is the umbrella under which data science resides as well. And for most of my life, I've been thinking about data, either generating it through simulations or collecting it through observations, lab experiments, or observations in the real world. So it's absolutely fascinating to think about data and to work in this space. And one of the things that we in the School of Earth Sciences that I'm part of at Stanford University really think about is the Sustainable Development Goals of the UN. And many of my colleagues are working in those areas. And of course, data is also strongly penetrating this area, right? You are here as in the data science conference because you're interested in data science. So you know that data is everywhere at the moment. And I've always liked to spend just a minute thinking a little bit about data and why we are in this space now, and why this is so important for us to think about women also in data science. And that's really because of this penetration of data. And it is no wonder when you actually start thinking a little bit about how much data there is in the world and how much data is really increasing. So I'm going to cover a slide in about a minute. And in that minute to cover this slide, we will have approximately 4.5 million YouTube videos that are viewed. 1.4 million swipes on Tinder, if you happen to use that. You know what I'm talking about. 200 million emails will be sent. Maybe some of you are sending emails as we speak, multitasking. There will be 4 million internet searches taking place in this 1 minute. So these are numbers that are really quite mind-boggling. And it was very different when I was a student. So when I came to the States in 1990. It's hard to imagine this for me, and I'm sure Bhavani and Latifur and others will feel the same. That things have so rapidly changed. So between now and Sunday, so just in 2 days, we will have 2 billion tweets sent, 16 petabytes of data created on Facebook, 260 billion messages on WhatsApp. And from today till next year, well, it probably is a little bit less now because of the current COVID crisis, but the prediction was that we would have about 400 additional satellites go up. And these satellites, of course, are observing the Earth, are helping with communication. So they're all really focused on data as well. And the estimates vary, but on IT, we're spending around $4 trillion per year now in the world. So, and this is just, all the examples I'm giving you are mostly to do with social media, with communication. The satellites, of course, are also, focused on Earth observing systems. I remember when I was a student, we were incredibly excited when the first Earth observing system was launched, and there were 6 or 7 satellites going around the world, and we would receive data from that from time to time. Now, with companies like Planet, with companies like Google, we have unbelievable detailed satellite data available to do our research. So anyway, it's absolutely no surprise that data is really penetrating all areas. And as a scientist in the computational field, it's also really interesting to think about how the science approach is really shifting. So when I was a student, most of the work that we were doing was, I would say, data supported. So we would write tools to simulate processes, and we would gather data with the purpose of informing the models that we were creating. So the models were supported by data. And then gradually, as more and more data became available, you would have data-inspired research where you would gather data and you would look at data, you would find interesting patterns, and you would get excited about maybe modeling that. And you wanted to understand more through the models. So that's this space of data-inspired research, and in many areas are still data-inspired research. And we are also seeing more and more this data-driven research, where really it's all about the data. In fact, I see in my field, people move away from the traditional simulation and optimization tools and really relying solely, at least that's the hope, on data approaches to solve their problems. And I'm a little worried about this, and maybe I sound like an old person saying this, because I think we have to be really careful when we're solely data-driven. And I do want to spend a little bit of time talking to you about that. So data really has become the new bacon, if that's the expression you like, or the new oil or the new gold. It's big and increasingly critical, right? And so when you think about just artificial intelligence, which by the way is nowadays often seen to be deep neural networks, right? Deep learning. That is to grow so much in just the next couple of years. And again, the predictions are a little bit all over the place, but when you think about it, the amount of money invested in this is really quite mind-boggling. Now, one of the things that I find exciting, and this is one of the reasons why I really like this field of data science, is that it is really bringing together so many different people. So it's bringing together humanists, social scientists, as well as computer scientists, mathematicians such as myself, and statisticians. economists and business strategists, lawyers and policymakers, and of course, domain experts in all areas. And this is clear because data science is now used to answer big questions. And when you're answering big questions, you need to, of course, really work with domain scientists. The questions that you're asking have really big implications for society. You need to understand how humans come into this. So humanists are really important. Everybody really comes together in this field. And sometimes, students who are really interested in data science, they're asking me, well, should I be a computer scientist or a mathematician to enter this field? And the answer is no. We see in data science people from all kinds of areas enter. And one of the wonderful things, of course, is also that there are companies, and you see this also in Silicon Valley, are hiring people with all kinds of different backgrounds. So also in Sustainable Development Goals, data have become incredibly important. And like I said, this is what's driving our school at Stanford University. Here are just some examples of what data is being used for right now. And it's not difficult at all to go around and find examples of this in the media. So in newspapers, you'll see all kinds of articles about detecting fraud or determining insurance premiums and how data comes into place there. Of course, there are also many people worried about the application of data science. People talk about how data science approaches can be used to automate weapons or skewing public opinion. We hear a lot about fake news. There's a lot to do with fraud. We have much concern that people talk about with face recognition and so on. But of course, there are also very, very good things that we can get out of this. So here you see different colors on this slide. When I look at this field, I think these darker redder colors are areas that I'm concerned about myself, and the whiter ones, the lighter ones, are ones that I think have a very positive impact, and it's a little bit all over the map. It's no surprise with all of this money, of course, that the number of companies is just exploding. I am currently in Santa Cruz, which is a little bit off the map, sort of to the left, the bottom left of this map. But my work and my previous home were right here at Stanford University in Silicon Valley. We're smack in the middle of all these companies. I know Dallas, of course, and Austin and Houston are also all centers of data science. And you can see many of the companies that are known in this space are directly around us. So no surprise that at Stanford University, of course, we're really focusing on this. And maybe also no surprise then that in this area, we really started thinking about women in this field also, which I will go to in just a few minutes. So what do data scientists and engineers really do? Well, sometimes people think about data scientists as people now that use machine learning tools. But data scientists and engineers, of course, do everything really in this space of solving problems. So within the field, very often people say there's sort of three different pillars. There's a collecting of data and then also correcting of data. And that's an extremely important part. We call this sometimes data wrangling or data remediation. There's analyzing and understanding data. So this is the field of data mining. And then there is applying the data and predicting out from the data, and that includes optimization, machine learning, deep learning, artificial intelligence, and a lot of focus is on this. But don't forget that as a data scientist or engineer, you also always help frame the question, at least you really should. And of course, at the other end of this whole process, you're visualizing data and reporting out and explaining data. And that's also a very, very important part of data science. Now, when I first put this slide together, I pride myself on being a woman in data science. We started Women in Data Science, and it's not just me, but it was also with Karen Mathis and Judy Logan, two really good friends of mine and who are my co-directors in this. And I put this slide together and I realized that the images I was using were all men. So that was interesting to me. And I really should replace them with women. So there are also women wranglers and of course, women data miners. And let me just put the WITS logo there for machine learning and artificial intelligence. Now, when you look at this picture, you say, well, data scientists and engineers do so many different things. But when you then start looking at the field and you start thinking about what people are publishing and what people are talking about, this really interesting thing happens. You know, here it's all about framing a question and then applying data science approaches to solving it, right? That's what I'm indicating here. It's this whole flow diagram that we're really framing the question is first. But what you increasingly see in the field, and this is one of my pet peeves, if you'd like a little bit, is that data often now comes first. And this is really no surprise, you know, when you have a situation where data is so abundant and so many different data sets are available, it's really not a surprise that people start looking at the data saying, oh, I have this beautiful data set, what can I do with it? Instead of thinking, what is the question that I want to solve? And in fact, what you often see now is that there is data and it looks to be beautiful. And then there is a tool, for example, a deep learning neural network tool. And people start just applying that tool to the data and seeing what comes out, and they publish this. And there's a lot of hype around this. You know, you have data, you have these powerful tools, people start applying it left and right, and there is a lot of hype in this field. So there's a lot of hype, there are black boxes, a lot of people outsource this. So say, oh, I've got data, I'm just going to hire a AI company or machine learning consultant and see what comes out. And at my age, I'm in my 50s, this really reminds me of a time in computational mathematics, maybe 25 years or so ago, when we saw the same hype, black boxes and outsourcing in computational methods for simulation of processes. I was working in engineering processes as a computational mathematician, and a lot of people in the simulation research community, they had the same. So the first commercial packages came out. It was a lot of public domain software, and people just started applying it left and right, maybe without really understanding the underlying problems. We started realizing this situation, saying, hey, this is not good practice. And the field came together in creating comparative solution projects, establishing best practices, establishing minimal QA/QC for publications, and really redesigning education and training. And one of the people that was really instrumental to this was a person called John McMasters at Boeing University, Boeing Company, because, like many other companies, the Boeing also started outsourcing. They started seeing that engineers that got into the company didn't really have all the skills that it took to really answer good questions. And instead of relying on open source codes and black boxes, they really started building more in-house capacity. And John even went so far as to revolutionize and change engineering education to make sure that engineers understood much more than just the black boxes. And I think we're starting to be a little bit in that same space. So see what was reported in the early 90s, 1991. John, who unfortunately passed away, said, engineers leaned too heavily on computers and didn't understand the data they were analyzing. And this is exactly what's happening right now. So if you start with data first, if you do this, and I actually think you shouldn't, but if you do, then it's really, really important to think very hard and deep about where this data came from in the first place. And often people don't do that. You really need to think about what's in it and what's missing from it, how to adjust the data for any imperfections that it has. And then you need to think what analysis are actually appropriate for the data, what questions the data analysis can actually inform about, what questions they cannot inform about. And very often you don't really see people think about this. How robustness can be measured, results can be verified if at all, what bias can and will creep in, and who needs to really be consulted to help out. But really what you need to do is put the question first. So I would say a crucial skill set is really to be able to think hard and deep about what tools are actually most appropriate for answering the question. And no, the answer is not always a deep learning network, a deep neural network. So sometimes when I look at the field right now, I think, oh, these deep neural networks are wonderful, and they're like big hammers that you can use for any kind of nail. And it reminds me of baby Bam Bam from the Flintstones, who had a really big hammer and was smashing everything left and right. So if a data study is in fact optimal for the question that you're thinking about, you really need to think about what's the most effective tool, what data should and could be collected, what data is available, is the data good enough, and how the data should and could be used. So that was me, sort of grandma here, giving you a little bit of what my concerns are right now about the field. Of course, there are many wonderful things about the field as well. So just a couple more observations from the review deck here in data science. People talk about this difference between calibration and prediction. That remains really important. If you find a correlation, it doesn't mean that you found causality. So that's always really important to think about. I also see another thing in the field that if you just have more data, then your algorithm will be better. That's not the case. You really need to understand what's in the data. Not all data that's in there is content rich. A lot of people find phantom patterns and relations very, very hard. If you do not really understand the underlying physics or the underlying human behavior in the data that you're looking at, it's really hard to distinguish phantom patterns from real patterns. A bias creeps in left and right, bias in the data, bias in your approach, bias in the tools that you're developing. And so it's no surprise that when you look around and you look at the media and you look at the science literature as well as the popular literature, you see many headlines like this. You know, they talk about the dark secret at the heart of artificial intelligence. They talk about how bias happens. They talk about how artificial intelligence algorithms are really not understood very well. So now there is this trend of, and thank goodness, of thinking about explainable data science as well. So in a way, for me, I think it's time to get our act together. You know, in this field, we need a shared glossary for one, and common language, robustness metrics, minimal robustness and trust requirements for publications. We need to think about reproducibility much more, sharing code and data. And we need comparative solution projects and benchmark much more than we have, and recognition beyond paper citations also in the fields, coding and data analysis. But there's a lot of good stuff as well, right? So there's tons of areas where data may be useful. Also in my field, so this is a little bit focused on my field. We do a lot of optimization. Fantastic to have a lot of data there. And this is for, as a computational mathematician also, improvement of linear, nonlinear solvers can really be helped by these algorithms. We can combine data-driven and physics-driven simulations. There's a beautiful interface of these approaches. And we can look at things like pattern recognitions and anomaly detections in engineering, the type of engineering that I've been doing. in earth sciences and energy. There are lots of ways in which AI and data science can help to make our lives better. And one of the things is with data wrangling for many of the alumni and graduates in my areas here. When I talk to them after they enter the data science field, they've been so excited about this and say, well, what is your life as a data scientist? They say, oh, I spent most of my time wrangling data. So tools in data science can actually help make that sort of a little bit less tedious. Anyway, but let's think about what kind of people we need to be really good data scientists. So strong data people, I think, are agile and diverse thinkers. And I'm emphasizing here diversity because it's so important to have people from different backgrounds, different ways of thinking, around the table to help solve these really important questions that we're trying to address through data science. And I just want to apologize for all these animations. I forgot to take them out. But anyway, I think you need to have people with strong foundations in math, stats, computing, physics, chemistry, but not just people like that. You need to have people that understand alternate approaches, maybe physics-based approaches, humanities-based approaches. You need domain expertise, people in there, so ability to learn quickly. And as a data scientist would of course be great if you had all of that, but it is absolutely not essential. Okay? You need first and foremost to have a really strong desire to learn from others, probably. No, that's clear. And you want really people who are critical, tenacious and stubborn, because this is not always an easy, it's a very exciting, but not always an easy job, and unafraid to learn from failure. So that's, that's how I see really strong data scientists, or the foundational data scientists. So anyway, it's a really exciting field. We need these diverse thinkers. And with that, under that light, in 1984, when I first sort of started joining this field, this was a question that came up for me. Where are all the women? Okay, so I started looking around, and Bhavani and Lynn and all of you who have been in this field for a while, we're still asking this question, but this was me in 1984 thinking, where are the women? So if you think about women in this field and in the general field of STEM, then it really the data are not great. So you have obviously data here too. So the percentage of women graduating with engineering or computer science degrees is around 20% maybe now, but that really hasn't changed much in 15 years. In fact, when I look at the percentage of women in my field in computational mathematics, I would say it's actually gone down since the 80s, since I was a student. And I remember when I started studying at the university, I was 18, thinking by the time I'm old, and guess what? I'm old now, according to my 18-year-old self, absolutely ancient. I thought this would all have changed and that we would have many, many more women, but it just hasn't really happened. And then when you look at percentage of women in higher level roles, both in academia and in industry also, they're far, far lower than men. And so that's really not great, particularly because data science has become so important. So a lot of decision making is now data driven. And we're finding us in a situation where the data driven decision making is done mostly by men. And there are still many, many meetings and conferences where people come together and all of the keynote speakers are men. So this is an example of a very recent one, Big Compute in San Francisco. No doubt a great conference, but all of the speakers were men. And there's really no need for that, of course. And this is one of the reasons why we started with WITS. So you may wonder, why is this? And so this is me 30 years later saying, well, it's still the same. And, unfortunately, a lot of this can be attributed to persistence of myths myths persist, cultures too. And it begins really very early on when people say there is this difference between men and women. So there are two myths that really lead to what we call stereotype threat and imposter syndrome that is really making it harder for women sometimes to enter or stay in this field. So one myth is that success in these fields requires very strong innate abilities, that if you do not have extremely strong innate abilities, that you cannot possibly be successful in this field. That is just not the case. This is difference between believing in a fixed mindset, that an innate ability is the only thing that gets you to success, or a growth mindset where you know that you can learn from failure, you can grow, and you can get better as you go along. So this is one really big myth. And then the other one is that girls simply have less innate ability than boys. So, or women have less innate ability than men. And that's also a total myth. But unfortunately, the combination of these two has really hindered us. So we have bias in this. Women feel just because they're women, they may not have the innate ability, and the innate ability is required, so they may not be successful. And it leads to bias. And of course, on top of that, if you have a predominantly male-dominated environment, then that tends to sustain itself. Now, it leads to something called an imposter syndrome amongst many women. And when I look at this at Stanford, for example, I see that female students often feel like imposters, much more often than male students say, I don't belong here. I don't think I can be as good as I need to be. I do not have what it takes. And that can significantly affect performance and joy in learning. And I'm absolutely also somebody who had this in my career. I've learned to turn this around. I've learned to overcome this, but it's absolutely there. But you know what? There are brilliant women in data science, and Bhavani, of course, should also be on this slide. And I apologize, Bhavani, you should have been on this, because you are one of the stars in this field too. Many brilliant women. And here is just a sample of 6 that we have seen coming through Women in Data Science, but we now have thousands of women that we have featured. And so we started WITS to really inspire women to join this field, educate everybody regardless of gender by having technical conferences that showcase outstanding work done in this field by outstanding women, and thereby supporting women in the field. We wanted to show people who were organizing conferences that it was easy to find good women in this field. There were so many conferences that were organized. And then when I was asking the organizers, why do you only have male speakers or very few women? They would tell me, we just can't find any. Or they would say, well, we asked Susan, but Susan couldn't make it. Well, guess what? There are thousands of Susans. So now we have this network. And if you ever want to organize a conference, you can just ask us and say, hey, give me a good female speaker. So we started in 2015 with just one conference at Stanford Universities. We had Stanford University, we had 400 people attending, but then we found 6,000 people on the live stream and we thought, wow, we hit a nerve. And now 5 years later, we are all around the world, which is amazing through the efforts of ambassadors like Bhavani and others with regional conferences everywhere. And we have so many ambassadors all around the world. We've had many WITS conferences already thus far. Here are just some selfies and other pictures from conferences around the world, including conferences in the Middle East, in India, and Africa, everywhere. And of course, we've also had to adapt when COVID started. And I'm so happy that in Dallas, we're doing this now, be it virtual. This is a picture of Tokyo. They moved from a face-to-face conference to an online conferences in a matter of a week, and you will see social distancing here in action. So we had our conference early March, and we had people, women speaking from 11 different countries. So we're really truly global. What I find so incredibly inspiring is the WITS community that we've created. There's so many fantastic things going on with many WITS stories, with girls and women saying that it has helped them a lot, which is incredibly inspirational to me. So here are two examples of Dorothy from Ghana and Sarah from the United States. Joa here, Joa Salinas from Colombia, one of our WITS ambassadors. She's now in Sweden. And Jyoti and Dishti from Mumbai, India, twin sisters who really got into WITS and were inspired by it. And that just makes me so very happy. WITS is more than a conference. We also have a datathon now for 3 years. And this year we had over 900 teams working on a health problem where we looked at predicting the fatality rate of people entering the ICU based on data collected at MIT. So sometimes, you know, when you have datathons, the hardest problem is actually find really good data sets to work on. And our idea of the datathon is to really get girls to try this out. When you look at Gaggle or other hackathon platforms, you will see predominantly boys and young male students entering, but we wanted to give a boost to the girls here, and we see many first-time participants, and that's really wonderful. So here were our Datathon winners of this year. I just want to point out on the left in the upper part is a mother-daughter team. So that was one of the first mother-daughter combinations that we had, which was just wonderful. And there are people from all over the world participating. We also have a podcast show so that we can keep the community going. Even in between conferences. Most of the time our conferences are in springtime in the Northern Hemisphere, so fall in the Southern Hemisphere. But we now also have this podcast series, and I'm hosting this, and it's my absolute delight to do this. And I just wanted to encourage you to check out our witsconference.org website that has all of this. We have lots and lots of talks listed there from previous conferences, the podcast. We also have an outreach program now for middle and high school students. If you are listening in and you're a high school teacher, please reach out to me. We've got some interesting materials available now for high school students, including a small outreach video, a short outreach video of about 5 minutes. And if you're interested in becoming an ambassador to WITS, then please also connect with us. So I just wanted to end here and leave some time for questions, which Bhavani asked me to leave about 10 minutes. So I'm glad that I managed to leave around 10 minutes for that. And I would want to encourage everybody here to participate in this incredibly important field. That really needs diversity around the table, that really needs women to come around the table as well. Also, of course, not just because it's important to have everyone contributing, and when you're making decisions based on data that are benefiting or at least influencing society, you need everybody in society to be around the table. In which those decisions are made, in which the data is being probed, and in which solutions are being created. And so women are absolutely part of it, like any other underrepresented group. You know, we need to get them to the table. So support each other and teach each other, encourage each other. And then the other thing is there are amazing opportunities in this field of data science for careers. There's a lot of money generated in this area as well. So it becomes a matter also of distribution of wealth. We want women to be part of this. It is the other thing that I just wanted to mention. One of the reasons why I'm so happy to be global with WITS is that in contrast to many other areas and many other industries, the data industry is not geographically limited. Anybody in the world can participate in this. You need access, of course, to data, and you need computers, but you do not need ore or mines or other resources that may, oil, for example, that may be geographically limited. So this could be an area, and this is an area increasingly so, in which we are truly seeing activity at the global level and helping educate and inspire women all around the globe. So support and teach each other, hire and promote each other. And thank you again, Bhavani and others, for inviting me to be here. On behalf of all of WITS at Stanford, myself, Judy Logan, and Karen Mathis, the co-director, everybody else in the team, and all the other ambassadors around the world, it's been my absolute pleasure to talk to you.
Thank you very much, Dr. Gerritsen, Margot. It was a fantastic, such a motivational talk. I have several questions. It's all on the chat, so I'm going to read these questions to you. But before I start with other questions, I have a question myself. That is two-part, actually. What is it that motivated you to start such a successful and huge organization? And what is it that you did to make it into such a huge organization? So what is the motivation, and how did you manage to make this into a great organization?
Well, thank you for saying it's a great organization. Makes me feel good. Of course, as a woman in STEM, I have always lamented the fact that so few women joined me. And ever since I was a student and saw this, I wanted to help out in that area. And I'm delighted that WITS has become the vehicle for doing that. So for my personal motivation, I really, really want to see more women in this area. Also because as a teacher and educator at university, I see so many girls and women struggle for the wrong reasons. You know, women dropping out of computational sciences, dropping out of STEM because they think they don't have what it takes, whereas I know they do. And that is such a shame. And I see so much stress amongst women too, doubt and stress and anxiety that really doesn't have to be there. So I've always wanted to really try to help change the culture. And you can change the culture, and you can change that by having more women there. So to normalize that there are women there, and to really see that these myths that I talked about earlier really are just that. They are myths. Now, why particularly women in data science? This is a small story. It was really, to be honest, a bit out of frustration that we started with. So early 2015, I was asked to give a talk at a data science conference in the Bay Area in Silicon Valley around Stanford. And I could not make it. I was traveling, and I had to say to the organizer, I'm sorry, but I can't make it. And so a little bit later, I saw the program for that day, and I realized there were only male speakers. And it just got to me, said another conference with just male speakers. And so I reached out to the organizer and I said, John, why only male speakers? And he says to me, but Margot, we asked you and you couldn't make it. And it really hit me so hard at that time. I said, but this is crazy. So I asked him, said, but John, there's so many other women you could have asked. And he says, well, we really tried to find them, but we just couldn't. And I thought it was outrageous. And he was right in one sense, that if you Googled at that time, even 5 years ago, women in data science, or you looked at people who were interviewed in podcasts, or people who were writing blog posts, or you looked at software submitted in GitHub, or women giving talks at conferences, you would find very few. And so I was having a cup of coffee with some friends of mine afterwards. And just over that coffee, we decided, you know what, let's have a conference where we just have women. Why not? You know, there's many conferences with only men. So, hey, let's just have a conference where we only have female speakers. And I was directing a program at the time on campus. So I had a little bit of money and I had some resources, some human resources, you know, people who could help me with this. And I said, you know what, let's do it from this institute that I was leading at the time, and we'll just start this. And this is, and we'll do this in 6 months. So we set this up in 6 months and had in November 2015 our first WIDS. And then we got so much traction. We had a choice to make. That was either scaling it up and become like Grace Hopper, a really, really big, wonderful, wonderful conference, really big conference where people would get together in one place. But at that time, I thought we should try something new and said, no, let's scale up. We want to be global. We can't possibly ask people from developing countries to all come to the United States. We also want to inspire people locally, because it's one thing to come to a big conference in the United States at a place like Stanford University and be inspired. But it's much easier to be inspired if you see somebody in your own area, in your own environment, do the things that you would like to do, because then you can really say, hey, if she can do it, I can do it. And so we wanted local conferences all around the world. And we suggested, and I sort of came up with this idea of, hey, let's do this through a distributed conference, but like distributed computing, and have local events. And then we would do the live stream at Stanford that other people could use. So, but they could supplement the central conference with their own programming, and that just took off like crazy. So the first year we had 75 conferences around the world, and now 3 years later we're over 250.
So I think there are two more questions, one from Q&A and the other from the chat. So I think you were really far thinking, Margot, because look, if something like Grace Hopper, it's going to be really hard to manage right now with what's going on, COVID. But your conference can easily be moved virtual.
Yeah.
So that's a positive.
Yeah.
And also getting everyone, all around the world. That's the main thing. So I've got a question from Greece. Vanna Kalagoraki. She's actually a good friend of mine. And in fact, if ICDE goes to Greece, she and I are planning together with our ladies' man, Latifa Khan, to have WIDS. And of course, Stanford will be the key. We need to get your, support and participation at IEEE ICDE. So Vanna asked the question, there are many talented undergraduate women in Europe, or Greece specifically. Are there any exchange programs or ways particularly focused on women for them to visit not only universities, but especially US-based companies? I think this is an area we in Europe are lacking. So again, from a WIDS point, this is a more general question. For a WIDS point of view, can they come maybe under this WIDS umbrella, come and spend some time at Stanford or maybe any other university in the US, and a company as part of
yeah, it is such a great idea. So we have talked about this a lot. Right now the WITS organization is very lean. It's the three of us together with some consultants we hire, and they're phenomenal, but it's really a very small, lean team. And we're gradually expanding. And this is something that we've thought about. At the moment, we have a meeting every Northern Hemisphere summer at Stanford University, where we're inviting WITS ambassadors, and it includes often students as well, who are ambassadors at the universities. They come to campus and to participate in our data science short courses that we offer around that time, and to get to know each other. And we've talked about this. We've really talked about it. And I would love to set this up. There are universities that do this independently. So I know at Stanford, we've done this in the past. We're inviting girls from a particular organization. And of course, now with the network that we have at WITS, this would be amazing. And so it's our dream. And we're hoping to do this in collaboration as we go along. So anybody who really is interested in this, like Vanna or you, we should talk and see if we can get the funding together and the support together to do this.
So another question, there are two or three. I know we are sort of running a bit late, but I really want to take advantage, Dr. Goritson, while you are here. Ling Liu from Georgia Tech, she's going to be she's a panelist, and she's also going to give a talk later. She has a few questions, but one question from her: any statistics on the percentage of women in the last 5 years who share their success from the program? So by coming to WIDS and participating, do you have any percentage on that? And also she asks, how do men professionals involved in WIDS to help some women scientists, especially young women? I think for that we have someone like Latifah, but if you can maybe, Margot, give some of your thoughts to these questions.
Well, first of all, with the statistics, the short answer is no, we don't. We have anecdotal evidence. And this year, through our ambassadors, we're trying to gather some of the statistics. So we've seen a lot of examples of women come to the United States, for example, from other areas. And when we ask them, and then we see it in their application at Stanford, say, I'm applying here because of WITS. I never knew I could do this. And now I'm doing this, but I don't have any numbers for that. So we know we're impactful. Which is wonderful, but we don't know how impactful. And of course, it's really important. I mean, we should collect data. We're a data science organization, so we're doing that right now. It takes a lot of time and effort, but through our ambassadors, we can do this. Men are really important for this. We have a lot of men actually as ambassadors too. Mm-hmm. One of the first supporters of WITS was sitting with me around this coffee table in spring 2015, Esteban Arcud. He was one of the first sponsors. He's been incredibly important for the WITS organization. And in our local organizing committee for WITS Stanford, we have several men who have been with us for many years. We need men, of course, because without them, I mean, they're the majority right now still. So we need to help them to support women as well. Not because women are weaker or cannot do this by themselves, but purely from the numbers. We need men who understand that there is bias. We need men who understand there needs to be cultural change. We need men who are in position of power and hire people to say, let's hire more women. Let's make sure that we're not biased against them. Let's try to understand how we do hiring. Let's try to understand how we do promotion, and if we're subconsciously disadvantaging women. So men are incredibly important, and we draw them in. The only thing which does is that we feature outstanding women speaking. Everything else is open to everybody.
So, Margot, I have several other questions, but this is, this is something interesting. I think that we should, I wanted to read it out. This is from Joanna, I think she's from Trinidad, Joanna MF. Trinidad. Thank you so much for starting this conference and your continued support for women inclusion in data science. What would you say was some of the specific challenges you witnessed women experience in the field? What advice do you have for us to help navigate environments that are less supportive of diversity, yet have interesting research/technical challenges? Yeah,
that's a great question. So I can answer this from my own personal experience, and it's actually something what I've experienced myself in the challenges is quite common, and that is simply related to the fact that you're different. When you're different in an environment, when you're the odd one out, it is much harder to get your voice heard. Because you're different, you tend to be scrutinized more than others as well. You tend not to be automatically included in support groups, in networking groups. And because of all of that, and because you may approach problems a little differently, or you may just have a different cultural background, you may feel that you do not really have what people are looking for successful people. So you may feel that you are judged in different ways than others, and it becomes sometimes, really hard. I find myself the hardest thing about being often the only woman in groups throughout my career. Luckily, that's changing in the last couple of years, but very often I was the first and only woman in any group that I entered professionally. Was this scrutiny that you feel that people are always judging, and that can be very debilitating. Now, there are several approaches. I have always disliked, and maybe that's too strong a word, but I've never found it useful to think about leaning in. So, Sheryl Sandberg wrote this book called Lean In, but basically the message seems to be that you have to adapt to the culture in the workplace. I haven't found that useful. I don't think that is the way to do this. What we have to do and try to do is to change the culture we have, and the way to do that is to have more people in there. So I am all in trying to work on getting the numbers of women up. I think that if you get to a critical mass, maybe about 30%, then a group ceases to be different, ceases to be different than the prevailing culture. It starts to influence the culture. And I've seen this, for example, in my institute. So I have this Institute of Computational and Mathematical Engineering that I directed for 8 years. When I started in this institute, we had 5 to 10% female students, really low. And when I left, we had over a third. And we really very actively looked for women to join us and girls to join us, and there were plenty, and they were very successful. So there really was not any reason not to admit them. And I saw this change from 5 to 10% to a third really changed the culture. And things like scrutiny and unconscious bias and women feeling left out totally disappeared. And this was to the benefit not only of the women, but also to the men. Mm-hmm. And I think it became a much more collaborative, inclusive place to work with much more emphasis on teams. And that is not because women are superior to men. I'm not trying to say this, that men cannot do this, but it helps to have diversity. Somehow, when you have this diversity in the group, it becomes more natural for people to really work together and to see and appreciate all these different points of views that people bring to the table. And so that's been wonderful to see. So that is what I'm hoping for. And that's what we're working towards, to get up to critical mass in the field. And then I think we'll see change. And to get to this critical mass, we have to really carefully look at the way we're hiring. If a company, if a university is not getting up to 30%, maybe, and I think so, that is not to do with the fact that there is not a pool. This is to do with the way that we're selecting. Mm-hmm. And time again, when people change and really become conscious and aware of the way they're selecting, they see that they're biased, that they're looking at a certain profile, not because that profile is going to be the most successful profile for people in this field, but because that's the profile they're used to. And they're used to it because that is what people have been in the past. So we need to really understand this, change the culture, and then leaning in and adapting as a woman to the culture is not necessary. Then we're helping change this culture.
So Margot, just one last question. It's a two-part question from two people. And the reason I know we can always, I know others might get, that we are running over time, but we can always cut back on lunch a little bit because we're all home anyway. So we can always grab a sandwich. But this question is interesting. It's coming from two people. One is, they're technical questions. Karuna Joshi, she's going to speak this afternoon. And then Latifa Khan, of course. They are somewhat related. Karuna's question is, so one of the biggest challenges data science is it's a digital divide where researchers don't have access to same data sets, with some having higher access in data generating companies, like the social media data sets, so the question is WITS planning on creating a shared data repository for all researchers? And a related question Latifa has, is WITS arranging any programming competition related to data science where only female students can participate? So one question is WITS creating a shared repository. The second question is WITS organizing any programming competition for female students. And with that, I think we are going to end all the questions.
Okay, well, the second question is easy to answer because that's our WITS Datathon. Yeah. And I have to say, and so we did this to get a really low barrier hackathon or programming challenge for girls and women, because we know that in Gaggle and other hackathons and programming challenges around the world, girls do not participate because they tend to be a little intimidated. And this is because there is this myth that they may not be as good as the boys or the men, and they feel that they're behind. You know, it is true that a lot of boys and young men have a lot more programming experience than girls at that same stage, and that's being interpreted by the girls as, oh, they have so much programming experience, we're really not going to be as good. The thing is, it doesn't take very long to catch up. You know, and the girls that enter this, they see this, they see, okay, yeah, they've done a lot more, but I can easily catch up. I can be just as good. With some support. So we started the Datathon for that reason. Now, what we did not want is to say this is only females. And this was also made a little bit harder because we're working together with Gaggle. And in Gaggle, they didn't really want to do this. But we said, you know, let's do one thing. Let's make sure that every team, and that is the limitation, the requirement, is at least 50% female. Because ultimately that's where we want to go. We want to go to a place where we have equal participation. So we have loads of teams in the Datathon that are female only, and we also have many teams that are 50-50. And so that is, and we see that having that saying 50% needs to be female is enough to break that barrier. So that's nice. Now the data divide is an incredibly important question. And I said, at the end of my presentation, one of the things that I find so exciting about data science, that it seems to be possible to really democratize this, to have this everywhere in the world, because we don't need the natural resources that are geographically limited. But of course we need data. And in fact, the digital divide is not just globally seen, but this digital divide is already taking place even in Silicon Valley. So there are a lot of people who are saying, oh, data science is so amazing because we're democratizing. There's public domain software that you can download. We're sharing data. But of course, there is a monopoly, just like in any other field. And the big companies are so successful because they have a lot of data that other people cannot have. So when large companies say, no, we don't have a monopoly, we're sharing, we're openly sharing, of course, that's really not true, because they're sitting on IP and data that they only have. And not just that, but if you want to do deep learning, which is, you know, an AI, and really try to make a difference, you need to work on very, very large data sets. And for that, these deep learning algorithms are extremely computationally intense. So you need very, very large computers. So yes, you can throw out in GitHub or other repositories your deep neural network code and say, hey, I'm contributing, everybody. This is liberated, you know, everybody can do this. But if you don't have the computational resources to run this, so it's not that then you can't, you know, it takes an unbelievable amount of time to run this. In fact, it's one of the problems in AI right now, is that the better solutions in AI are really only achievable if you have unbelievable hardware and time and money. And so an incredible amount of power sits with these big companies. So we really have a big problem now. And this problem is exacerbated because right now people are believing that only really through these huge AI algorithms you can answer these questions. Now, so one of the things I said in my talk is that that's not always the case. You know, many questions can be answered on smaller data sets with domain experts, and we really need to not only think that AI and huge AI can do that. So that's part of the hype right now. But the other thing is a real danger is that we're allowing these companies to have this monopoly, and we're allowing, therefore, to have certain parts of the world to have this monopoly. So that's my soapbox. What to do about it? Yes, data repositories are incredibly important. There are several NGOs working on this, universities working on this. Really hard to do because it's very expensive to set up these repositories. We're trying to get support for people. I have been trying to promote this through WITS. WITS itself, we're not quite powerful enough right now to do this, but I think that as a WITS community, this is something that we can really do. So with all our ambassadors who have influence at companies, we can try to set this up. And the same, I would say, with access to hardware. That would be equally important. So I think and I'm so happy for the question, Karuna, you hit it on the head. This is incredibly important, and we will not be achieving global data science and true democratization without it.
So thank you with that. Thank you so much. And I want to give Dr. Gerritsen a hand.
Well, thank you.
Yeah, thank you. This was such an honor. And I'm sure, Dr. Gerritsen, we are going to have many more WITS members. So hopefully you'll have, I'm sure UMBC, Purdue, Georgia Tech, they're all going to have even more participation and also international. And hopefully we can have this collaboration between IEEE data engineering and WITS, Stanford, and wherever WITS, the local city. So maybe it's going to be Athens next year. It hasn't been confirmed yet, but so we'd like to thank you, and we are all so very grateful. Thank you very much.
Thank you again. And I'm signing off now. Unfortunately, I have to go teach, so but good luck with the rest of the day.
Thank you. Thank you. Bye. So, right. So now we go to our featured address. So this is how we are going to organize. So I'm going to introduce the first part. So Dr. Gerritsen and now Dr. Bertino. And then my colleague Latifa will do the second session. And then I will do the third session, Latifa the last session. And also we may have to cut back because we've gone about 20 minutes over because I really wanted the whole world to listen because